Okay, so now let's identify key features and draw the graph all at once, right? So to identify key features, we need to make sure we can get things in factored form. I went ahead and wrote the factored form here. Take a moment to make sure we understand that x squared plus 6x plus 5 can be written as x plus 5 times x plus 1. That 2x squared plus 7x plus 5, because 2x squared has a prime coefficient, I know 2x and x have to be the first parts. And then in order to add up to be 7 and multiply to be 5, I need 2x plus 5 and x plus 1, because 5x plus 2x is equal to 7x, and 5 times 1 is equal to 5. Over here, we already have our x plus 2. X squared plus 2x plus 1 is x plus 1 quantity squared. Denominator, I have a common x that I could factor out, and that's x times x plus 2. In that factored form, before I simplify, before I do anything, that gets my domain. So my domain, x is negative 5 halves, x is not negative 5 halves, x is not negative 1, because I don't want the denominator to be 0. Domain, x is not 0, x is not negative 2, because once again, I do not want the denominator to be 0. All right. Then, once I simplify, so here x plus 1, common factor, here x plus 2, common factor. Once I simplify, I can have my vertical asymptotes. So I'm going to have a vertical asymptote for this one at x is negative 5 halves. And for this one, I'm going to have a vertical asymptote of the y-axis at x is equal to 0. Horizontal asymptote, I can look to the ratio of the leading coefficients if the degrees are the same. So there's an implied one here, 1 to 2. So my horizontal asymptote is going to be y is 1/2. All right, horizontal asymptote for this one. If I look to, I have x squared in the numerator and just x in the denominator, so not a horizontal asymptote. Degree of the numerator is greater. All right, I either have a horizontal or an oblique for what we're doing, so this one will not have an oblique asymptote. X-intercept is going to come from the numerator when the numerator is equal to 0 and in simplified form, so negative 5 comma 0. And for this one, my x-intercept is going to be negative 1 comma 0. And notice my multiplicity right, that I still need to take into account. So I've got a multiplicity of 2. So I know I'm going to bounce at the x-axis at negative 1, 0. Y-intercept, what happens if I can equal 0? For this one, 0 is in the domain, so 5 to 1. So that is going to be, right, 5 divided by 5 is 1. For this one, x is not in my domain, or x is 0 is not in my domain, so I cannot have a y-intercept, right? It's okay if you write none rather than NA, that's fine. Okay. If I want to find the oblique asymptote for this one, I have, right, x is equal to 0, and I have x plus 1 squared. So this becomes a little bit weird, but I can do long division always. So I have x squared plus 2x plus 1. We'll say x goes into x squared x times, so this is x squared, right? And if I subtract, that's going to give me 2x plus 1 here. X goes into 2x. That's going to be 2 times, so plus 2. So my oblique asymptote is y equals x plus 2. Right? There are other ways to approach this that I could have seen. Hey, what if I divided this term by x and that term by x, left with x plus 2? But set up the long division. It'll always work for you. So we have our items. So now we need to identify our holes. So our holes is going to be for this one, if x were negative 1. So if x could be negative 1, I would have negative 1 plus 5 over negative 2 plus 5, which would be 4 over 3. and so my whole is at negative 1 4/3. For this one, if x was negative 2, right, is going to be where I have my whole. So if x was negative 2, I would have, what would that be? Let's see here, negative 2 plus 1. So negative 2 plus 1 quantity squared all over negative 2. So that's going to be positive 1 divided by negative 2. So that's going to be at negative 2 comma negative 1/2. So now I have enough information to draw my graph. And I will plot all of those key features first. To be able to get what I need. So for this one, horizontal asymptote y is 1/2. So let's draw that in. And my computer is starting to lag a little bit. That's okay. All right, so y equals 1/2. Here, oblique y is x plus 2. Right, vertical asymptote of x equals 0. Vertical asymptote x is negative 5/2. Okay, x-intercept at negative 5, 0, so x-intercept is somewhere over here. Y-intercept at 0, 1, so y-intercept is somewhere up here. I gotta be able to follow my asymptotes and connect the dots. So follow the asymptote and connect the dots. I'm gonna draw my asymptote a little bit more on this side. So there's my first graph. But I have to be careful. I had a hole at negative 1 4/3. So that hole at negative 1 4/3, I've got to be able to come in and graph. And so that hole is going to be somewhere over here. So I'm going to go ahead and draw in the hole and then set up to finish my graph, right? Good form is to label your axes, but because we do have everything identified over here and we don't have much space, be sure that you do label the asymptotes, and unless specifically asked, draw what you have. Okay, for this one over here, we don't have a y-intercept, so I know I'm not going to cross the y-axis. My x-intercept happens to be at negative 1, 0, and it has a multiplicity of 2. So my x-intercept, if this is x plus 2, so I know my x-intercept is going to be about right there, because I know that that's 2 right there, and that's negative 2 right there. So I have to bounce off of the axis and follow my asymptote. So my graph looks a little something like that. And then over here, right, we'd need a calculator to figure out exactly where this minimum is. But this maximum is then clearly at x is negative 1 with the maximum value of 0. So there we have our graphs. Not easy to do. Take some steps, take some practice. Make sure that you're asking questions for clarification. Make sure that you understand the details. Come in for more practice as needed. Thank you for your time.